When we graph trig functions, the last question on that was that I gave you, remember, I gave you a parent function and a shift, and I asked you guys to write the equation. And most of you guys did absolutely just fine with that. I never showed you how to do that. I just pushed you to see if you could do it. And you did it. Today what we're going to do is use that same basic idea, but more than looking at just a parent and a shift, we're just going to look at the shift. We're only going to be looking at sine and cosine. Tangent throws this whole thing out of whack. We're not going to worry about it. So what we're looking at are the sinusoids of sine and cosine, trigonometric functions, and modeling. A lot of fun. Yeah, someone else asked that too. So I want to go back to how do you graph? And I'm going to just start with this and then show how it relates to what we're doing today. And it's, so far it's been pretty straightforward. Okay? So I have the function y equals -2 plus 3 sine of 4x. Now remember when we did sines and cosine graphings, they all matched the same basic principles. They all had the same basic idea. Y equals a sine b x minus h plus k. And when we did these, and this was the same for sine or cosine, they're interchangeable for the setups. When we did this, we always labeled our a, our b, and our h, and our k. Our a value allowed us to figure out our amplitude. Remember, we took the absolute value of a, and that gave you your amplitude. Your b value allowed you to work to find the what?
The sidewaysness.
The sidewaysness, which is called the period. It allows you to find the period because sine and cosine have a period of 2 pi over b. Your h and your k was your horizontal and your vertical shift. So in this problem, what's our a, b, h, and k?
4, 0,
A is 3.
A is 3.
B is 4. H is 6. K is -2.
There we go. What's wrong? It's 3 sine 4x. Remember a, b, a sine b, and the value in front of the sine, the coefficient of sine, if you will, that gives you your a. So now we know that our amplitude would be 3, and our period would be 2 pi over 4, which is pi over 2. So when we graph this, we would do one cycle, and what would I put out at the tail? Pi over 2. We'd start by putting out your tail at pi over 2. We'd mark the halfway point, and we would put that at? Good. Halfway between that and 0 is? And halfway between these two was? Getting those fractions after a while, because they wind up being kind of the same a lot of times, you guys did just fine. Your a value is just a matter of walking up and down. So you have to go up 3 and down 3. So a quick reminder, when you're dealing with sine values, sine of x always starts at 0. And then it goes to a. Cosine starts at a. And it goes to 0. Thank you. Done. In this problem, it was a sine graph, correct?
Yeah.
So where do we, when we go to plot our parent function, where do we start? 0. So I start at 0. I go to my a value, which is 3. If a value was negative, which way would I go?
Down.
Go down then. Goes back to 0. Goes to the opposite of a. Back to 0. One thing I want you to also to notice, I don't think you might not have picked up on this, sine will have 3 of the same y values. Starts at 0, goes back to 0, ends at 0. Everybody see that? Whereas a cosine starts at A, goes to 0, opposite of A, goes to 0, goes back to A. Cosine only touches the same value twice, same value of y. Well, it does it in a couple occasions, but you'll always have 3 of the same y values in sine. Cosine doesn't. That's how you tell the difference. When we did this, then we would just kind of go, we would dot it because it's our parent function. You okay with that? Now, what do we do to all those points? Shift them down 2. So all these points then got shifted down 2. And you wound up with a solid line that looked like that. And you would be done. So what we're going to do today is just work with that. We're just going to work with that. We're going to work with only the shift. And by working with only the shift, you can still identify all of the same parts. Because what I want you to notice here, the best I can draw, see how it has the same 3 y spots within one cycle? That tells you it's what kind of a graph. It tells you that you know that's a sine graph. Also notice that it starts, goes up, and then goes down, which means that your A value is going to be what? Positive. So A is positive. How many up did it go? It went up 3, and notice that it went down 3. So my A value is 3. But I didn't start at the origin, did I? Where did I start? Which means everything got shifted, which means you have a K value of, the K value of -2. This is a maximum, that's a minimum. Do you agree on that?
Yes.
The maximum value is at pi over 8. My minimum value is at 3 pi over 8. How far apart are they?
2 pi over 8.
So it's 2 pi over 8, so they're pi over 4 apart. You agree? The distance between these two is pi over 4. If I double that, I get my full period. What's my period? So my period is pi over 2 by doubling the distance between your high and your low. Now, according to the calculations for period, period is found by taking 2 pi over b. Could I solve that ratio for b?
Yes.
What's b? 4. So therefore, you've got your A, a K value, and a B value, and you knew it was sine because it had 3 of the same values here. Fill it in. 3 sine 4x, all minus 2.
How exactly did you tell us what P was? I don't have something to do with period.
We had the period. Remember, to find the period, you took 2 pi over b?
Yeah.
I solved this equation for b. That's it. 2 pi divided by what is pi over 2? b. b has to be 4. Because 2 pi over 4 is pi over 2. That's how these work. Yeah.
To find the period, is it the same to cosine?
Yes, because sine and cosines have the same period. You define the period is the same, because the period originally is 2 pi. Okay. And now, just to remind you, I'm not going to give you anything with a horizontal shift here. Because sine and cosine are just pi over 2 apart. Okay, so you won't know which ones you're dealing with. So always look at where it's at the origin. Okay. Did you guys have, do you have a question too, Molly, or it sounds kind of? Okay, I just asked you. Yes, sir.
Is there like a sine regression and stuff?
Yeah, there is. There is, and we'll look at it in table form probably more tomorrow. Today we're just going to look at the pure graphs. Okay. Yeah.
Are we also working on tangent?
No, we're not going to look at any of the tangent stuff. Because tangents throw a big monkey wrench in all of it because of the asymptotes. Okay? Yeah.
So that's the name of
Yeah. Okay. Let's look at another one. What's that, Emma? We'll get there. Come on. Let's take a look at this.
So it's like cosine?
I don't know. Let's wait and take a look. We are not worrying about any horizontal shift, okay? Because there is no way of knowing whether or not it's going to be a sine or a cosine graph, because the shifting could make it either one, okay? So what I want you guys to remember is that we're just going to look solely at what starts at what's going on at the origin, or the maximum and minimum. When we get into those 200 pairs, you're going to be able to identify what's going on, okay? Excuse me.
So let's say pi over 3.
Yes, it does say pi over 3. Take a look at your maximum and your minimum. Do both of those numbers have the same absolute value? Yes. That means they're both equidistant from the line y equals 0. So, is there a vertical shift here? No. There's no vertical shift here, because this point from here to 0 is 4. This point from here to 0 is also 4. The distance from the origin is the same. They're the same distance apart from the same line. What you want to think of is, if you want to find the midpoint, what's 4 plus negative 4? What's half of 0? 0. Now, if they were at 6 and negative 2, you could be shifted up from the origin. See how that looks?
Yeah.
That's what this looks like. So this one has no k value because it's all bounded around the line y equals 0. You okay on that? See how you're looking at me crazy?
Oh, no, I understand.
Okay,
Yeah.
just more so than normal. All right. So, in looking at this, it starts at a minimum. Which of the trig functions could start at a minimum, sine or cosine? Cosine. It has to be a cosine value because cosine is the only one that starts at an a value. In this case, what's your a value? Negative 4, very good. So we know that a has to equal negative 4 because that's where it's starting. Cosine always starts at an a value, whether it's positive or negative. Since it started at a minimum, it means your a value is negative, so it just means it starts there. It goes up to its maximum at 4. Now we do the same thing to find our b value. The distance between the two, the maximum and the minimum, is how much? Good. So that means if I take pi over 3 and double it, that will give me my full period. 2 pi over 3. So my period here is 2 pi over 3. I use that to find b. So knowing that it's a sine or a cosine graph, their period is found by taking 2 pi divided by b. What's b? 3. 2 pi over 3 equals 2 pi over what? 3.
Oh, I get it. I was multiplying by 3 and dividing by 2.
So you have an a value, you have your b value, and we knew there was no vertical shift to it because your 4 and negative 4 are the same distance from that line of symmetry. So you're done. Your equation is y equals negative 4 cosine 3x.
How did you find the a value exactly?
Notice that it starts at a minimum.
Yeah.
How far is that from the origin?
4 Oh, yeah, I tried. Oh, yeah, I used
Not horribly scary, I hope.
Nope.
Try to learn.
What do I need to do?
Hi, how are you? I'm doing great. It's good to see you. Stay out of trouble. All right.
That was a great conversation.
I don't know who that is. No, really, I don't know who that was.
At least you're really personable. It's a good talent.
So what?
It's totally worth time to look it up.
Yes.
It's good at interacting with persons.
Good with interacting with persons, yes.
When my sister was little, she called my dad
At like
forgettable,
a day.
and that when we used to forget, explain that she meant like my dad. So she was like, "Oh, Dad, you're so forgettable."
Yes.
There's also the impersonation. I mean, two girls were sorry impersonation.
But who?
That's like hard impersonation, like the child.
Oh, okay. Is that, which one's that?
The future one?
No, which one?
Oh, the school.
Oh, okay. So take a look at this. Look what happens now. Where does this graph start? It starts at -5. It goes up to +5. Goes down to -15, and then it goes back up to -5. What I want you to see is that it hit this inval. What is it? Sine. It's a sine graph. It has to be a sine graph, and you're right, it is shifted. It's been shifted what direction? Down. So we have a sine graph. We know it's got to be sine because you can draw this and it's going to hit it in 3 spots. Okay. What I want you to see here is your A value. Or better yet, look at the distance between maximum and minimum. It's 20, right?
Yes.
No, I'm sorry, 10. I can add 5 plus -15.
Yeah. I'm just gonna go along with what you said.
5 plus -15 is -10. What's half of that?
-5.
Look at what the line's going through. It's going through y equals -5. The maximum value is 10 above that. The minimum value is 10 below that.
Oh,
What's your A value? 10. Now, will this A value be positive or negative? Why? Good, because it went up first. Okay, everybody all right with that?
Yep.
Now let's take and figure out our B value. The distance between here and here is how much? Horizontally, it's how far apart? 1. So this value was 1. I double it to get the period. So what's the period? 2. So if my period is 2, I set that equal to 2 pi over b. What's b? Pi. So now I have an A value. I have a pi value. But what did we shift from the origin? -5. So I have a K value at -5. Since this moved down here. Since we're not doing horizontal shifts here, a lot of times it's nice to put the K value up front. So you can write it as y equals -5 plus, what's our A? 10 sine pi x. Or if you want to put in -5 at the end, it's okay. Just be careful not to throw it in parentheses. It needs to show. It takes a bit. Yeah, I'm not going to lie. It takes a minute or two to go, well, this is just kind of weird. You just have to systematically pull through it. So, do those two.
Wait, what was the name of these?
These are called sinusoids. Sinusoids. What's that? Yes. I've got her hair is long over her ears.
I've got a sinusoid.
take a second and try these two out. Look here, that's a great question. Isn't pi over 2 3 pi over 6? And isn't pi over 3 2 pi over 6? That what they're doing is that they're simple. We did all the same thing. We would say what it was. We would say, oh, it's 3 pi over 6, and we would write down pi over 2. We would simplify our fractions because that's what you do. But when you did your calculations, you got your common denominators because it was easier to do that in your head. So we switched it. So now, Tom, what's the difference between 3 pi over 6 and pi over 6? Which is?
2 pi over 3.
So you have 2 pi. So you have 2 pi over 6, which is pi over 3. The difference between the two then is pi over 3. You double it for your period, and you get?
Yeah, and then these 3.
So here, our distance between these two was pi over 3. I double it to equal my period. We get b equals 3. Now, this isn't like the Satan problems we were doing, where b is always going to be equal to 3. It doesn't always happen. Will this problem be a sine or a cosine graph? Yeah, the first one. And why is it sine? The 3 spots of 0. 1, 2, 3. And it also starts at the origin.
Yeah.
So we know that, bless you. Oh, there's no one. It starts at the origin, replicates through the origin. So is there a vertical shift here? No, there's no vertical shift. Our a value is going to be negative because it went down first. It went down how far? Do you have enough information right at the graph? Yeah. Y equals -1 sine 3x. Bless you. Can I write just negative sine 3x? Either one's fine. Okay.
What do we use the pi over 6 and the pi over 2 for?
We use the pi over 6 and that pi over 2, or pi over 6 and 3 pi over 6. We found the distance between the maximum and the minimum. It was pi over 2. We just wrote it as 3 pi over 6 so we can have common fractions to simplify.
The same as going from the origin to that labeled pi over 3.
It's double up.
Okay. So I thought that was in the middle.
It's a sine graph. It will be.
Also, you said double up.
As words go. And the other one you'll notice that it starts on the y-axis. It's not starting at an origin. So if I draw it from here through, I'm only touching it, oops. I'm only going through this spot twice. So I know it's not going to be a sine graph. Therefore, it's only going to be cosine. So this has to be a cosine graph. It's pretty nice when you can draw it through because now you'll notice how far apart is your A. If you look at your vertical distance between here and here is -2, which means the halfway point would be at negative. Well, sorry. Add these together, divide by 2. -4 divided by 2 is -2. This is a cosine graph. It's been shifted down 2. So your k value here is -2. Instead of it being at 0, it's at -2. So you know you have a k value of -2. I know it's cosine. The distance from here to your a value is how much? 1. It's 1. It starts at a positive. It starts above, so it's still positive a because it works its way down, and then it works its way back up. So your a value here is, well, how far is it from the shift up? 1.
When does A become negative for cosine then?
If it starts at its minimal. Remember we did that. We did an example of that earlier. And then how far apart is it horizontally? 1 apart horizontally for the maximum of the minimum. Double it, and you get 2 has to equal 2 pi over b to get your period. How are you? And you got enough info. It'll be -2 plus cosine pi x. You want to write it that way.
How did you find the
This 2,
Yeah.
the maximum and the minimum is 1 apart.
Oh,
Double it to get the period. So my period is at 2. So my period is 2. I set that equal to 2 pi over b. Solve the b and I get pi. All right.
Wait, you were doing this from the origin to the middle?
When?
Well, when you were looking at, are you talking about the maximum being 1?
I was looking at this point to this point. Yeah, I was talking about how far apart were they horizontally. They're 1 apart because the period goes horizontally. All right. What I want you guys to do is 14.5.
10 to 15?
Yep. Yep. There's more to this section. We're just not done with it yet. This is section 14.5. It's page 865, 10 through 15. I want you to do those tonight. And evens. Keep them all together. All right? Straighten out graphs. Okay? We'll do this a little bit more in depth tomorrow via ordered pairs. And we'll also talk about how you do the sine regression, sinusoidal regression. It's a button on your calculator. Yay! But how do you identify it from a table? Well, what do you think you're going to use?
L1, L2.
L1, L2.
Oh my God.
And what do you think the graphs are going to look like?
That.
That.
A sinusoid.
A sinusoid. Very good. You're going to see the repetitiveness.
Aren't you going to just those calculations?
No.
I really want to know.
You might not have to. You know, sometimes you don't need to. Sometimes people, if you just want to draw a single period on it, you'll be okay.
Oh,
They overdraw the periods of these things to kind of throw you off. How many questions? Yeah. Right now, I mean, it's going to be right around 15 questions. But a lot of them are really fast.
Oh, I said 3.
Shut this off.